So today's lesson was about subtracting polynomials still, but our essential question this time is how can you solve real world situations by subtracting polynomials? Should have a question mark at the end. Let's fix that. I'd like to. Oh. So anyway, so what we're really talking about here is like modeling situations, representing situations with polynomial expressions rather than just getting, answers to things. So here's our first example. Calvin has a mobile barber business. His revenue is represented by the expression 5H, where H is the number of haircuts he does, and his expenses are represented by the expression 27H. Write an expression to represent his profit, and then figure out what will his profit be if he does 150 haircuts. So I'm going to take this over to a blank sheet that a little bit of writing on it. So when you think about having a business, there are several streams of money. So if this is my business, the money going into the business is called revenue. Okay, so that's the money. Like if I, if I own a restaurant, that's all the money my customers are paying me that's coming into my restaurant. Now, my expenses are the things that go out. That's the money that I have to pay for things. So, for example, and this is all money. So that might be things like paying my staff, maintenance, buying food to cook in my restaurant, like buying ingredients, making sure that, we have the tools we need to operate and all of those things. Profit is what is left of the revenue after the expenses are paid. So to find profit, we're going to do revenue minus expenses. Okay. So if we look back real quick at the example with Calvin, his revenue is represented by the expression 50H, and his expenses are represented by the expression 27H. So his revenue was 50H and his expenses were 27H. So his profit, and I'm going to do this in function notation because his profit is a function of the number of haircuts he gives. So in other words, his profit depends on how many haircuts he gives. So as a function of haircuts, his profit is going to be 50 minus 27, which is 23 times H. So this is the first piece that we want. We wanted to write an expression to represent his profit. So that's what this first part is this is the expression that would represent his profit. And on a test or something, you probably wouldn't have to produce the expression, but what you would have to do is select it from a multiple choice menu. So now I want to know, what would his profit be if he did 150 haircuts? So his profit for doing 150 haircuts would be 23 times 150. And that comes out to be $3,450. So his profit after he's done paying his expenses for having his mobile haircut business, including paying himself. If you have a business, if you're in business for yourself, you need to make sure that you're paying yourself too, because that's your job. So you shouldn't just be getting whatever scraps are left over after, everything's paid for the business. You need to factor in how much you're getting paid as well. And after all of that is considered, he has a profit of $3,450. So, he might put that money back into his business, maybe upgrading his supplies, increasing advertising, something. All right. So now here's an example. Now, what I would like for you to do is take a look at this example and pause this, because in class, students did this themselves. So pause this for a minute, work on this video. I'll read it to you first, and then, or work on this question, and then come back and see how you did. So Carla sells cupcakes and cakes. Her revenue is represented by the expression 4.75x plus 45y, where x represents the number of cupcakes she sells and y represents the number of cakes she sells. Her expenses are represented by the expression 1.30x plus 19y. Write an expression to represent her total profit. What will her profit be if she sells 210 cupcakes and 3 cakes? So go ahead and pause for a minute, work this out, and then come back and see how you did. Okay, so we're going to use that same formula as on the previous one, except this isn't a function this time because we have two variables that are changing. You could have many different outcomes. Like if she sold 20 or 200 cupcakes, she could have sold 5 cakes, she could have sold 9 cakes, she could have sold 100 cakes, and all of those would produce a different output. So it's not really a function the way that it's written, because there are 3 different variables. There's 3 things that are changing. So anyway, I'm going to abbreviate this. So profit equals revenue minus expenses. So her revenue, I'm going to put this in parentheses because it's a whole expression. So that was 4.75x plus 45y. So 4.75x plus 45y. And I'm going to subtract from that the expression for her expenses. So 1.30 and 19. So 1.30x plus 19y. So what this tells me is she's selling cupcakes for $4.75. She's selling cakes for $45 because I've got the x being multiplied. That's the number of cupcakes being multiplied by $4.75. And I have the number of cakes, which is y, being multiplied by 45. Now, over here in the expenses, what this tells me is each cupcake cost her $1.30 to make, and each cake cost her $19. So now what I want to do is I want to go ahead and distribute a -1 so I can drop all these parentheses. So I'm going to bring down the 475x and the 45y. And then I'm going to subtract 130x and then subtract 19y. And then that was did you just hear him sneeze? Sorry. Okay, I want to try these sparkly ones down here. What are these? Okay, we're going to try that one. I don't know what this is going to look like. Okay, so now I'm going to combine my like terms. Ooh, that's kind of cool. I'm going to combine my like terms. So I've got 4.75 minus 1.30x. So that is going to be profit equals 3.45x. And then let's try this one. Sparkly. Okay. And then 45y minus 19y is going to be positive 26y. So that is my profit. That's my first thing. And remember, what you might end up having to do, like on a test or something, is it might ask you which expression could be used to represent profit, and you would have to recognize the right one. So that might be on like a SAT, ACT kind of test, or the EOC or something. But now we want to know if she sells, what were the numbers on that? 210 cupcakes and 3 cakes. So let's go substitute those numbers back in. So her profit, if she sells 210 cupcakes and she sells 3 cakes, I just put this in the calculator. You get like 700 and something for the 345 times 210, and you get 78 for the 26. And altogether, her profit is going to be $802.50. Not a bad profit, especially considering with her expenses, hopefully everything else is paid. Cool. All right, so moving along to example 3. The total area of the triangle shown is represented by our polynomial got cut off a little bit. Let me see if I can fix that. I can fix it. Okay, there we go. Let's spread this out a little. See if we can fix that. There we go. Now it's all in the same line. The total area of the triangle shown is represented by 5x squared plus 3x minus 8. The area of the white square is 2x squared minus 7. Write an expression to represent the area of just the blue space. So in order to do that, I am going to find the area of the whole triangle, and I'm going to subtract out the area of the square. So in this case, I don't have to find it. It's right here. There's the triangle area. There is the white square area. So I'm going to do 5x squared plus 3x minus 8. I'm going to do minus. This does not show up very well on that green, so we're going to switch colors. And I'm going to subtract from that 2x squared minus 7. And then I'm going to distribute this invisible -1. And this gives me 5x squared plus 3x minus 8. Now remember, you should be at some point working on getting this to where you're doing a lot of the steps in your head, but make sure that you're remaining accurate. And this becomes 2x squared plus 7. And now I'm just going to combine my like terms. So I have a 5x squared and a minus 2x squared. So that's this and this. So that's going to be 3x squared. And now I've used both of those. Now I have a 3x with nothing to pair it with. So that's just going to be plus 3x. And I'm going to cross that out because I've used it. And now I have this -8 and positive 7. So that's going to come out to -1. So the area of just the blue space, all this in here, is represented by 3x squared plus 3x minus 1. Okay, so I'm going to look at one more example of this. The total area of the rectangle shown is represented by 7x squared minus 2x minus 9. The area of the white square is 3x squared plus 2x plus 7. Write an expression to represent the area of just the blue space. We're going to do the same kind of thing. So pause for just a minute. Try it out on your own, and then come back and check and see how you did. All right, so I'm going to label this blue space. I'm going to label this rectangle the B for big rectangle, and we're going to call this W for the white square. So the area of the blue space is going to be equal to the big area, the area of the whole entire rectangle, minus the W, minus the space of the white square. So area of the rectangle is the big rectangle, is 7x squared minus 2x minus 9. And then the area of the white square, I'm probably going to run out of space, is minus 3x squared. You are possibly hearing the sounds of nighttime in my house. My cat howling like he's being murdered, but really all he wants is somebody to play with him. And I'm ignoring him for you, so now he's howling like he's being injured. I promise he's not. He's super spoiled. He just had a bowl of whipped cream. Okay, so now distribute the invisible one. This invisible one right here needs to be distributed to 3 things. And then we drop off the parentheses. So I've got 7x squared minus 2x minus 9. And then we're going to go minus 3x squared minus 2x minus 7. Those last couple, 2x minus 7. Okay, so now combine like terms. I've got 7x squared and negative 3x squared. So that is 4x squared. Done and done. I have negative 2x and negative 2x. That makes negative 4x. Done and done. And then I have negative 9 and negative 7. That makes negative 16. So the area of just this blue part in here without the white is represented by 4x squared minus 4x minus 16. Now, last thing I would like for you to do, and I would like for you to hand deliver this to me at some point very soon, is to write a question about adding or subtracting polynomials. So basically what we've been doing Thursday and Friday of last week, and then Monday and Tuesday of this week, that could be potentially be used as review. So be sure that you answer the question also. It could be a problem, like it could be, a simple addition or subtraction problem, like you give the polynomials and you just say add or subtract. It could be a word problem. It could be a vocab problem or a question. It could be a procedure question. Anything that might help a person review, say for a test. I would look back at your notes for some inspiration. You can always take one of the problems that we've done in class and just change the numbers around or something. You can look in the textbook. If you have a textbook at home, it's section 5.2. Otherwise, you can go online to the online textbook and just look for section 5.2. Any of those questions in there would be totally reasonable questions, to inspire you, not necessarily to copy the question, but just to inspire you. Maybe you could change around context, change around numbers, something like that. Just make sure that you also write down the answer. It just has to be the answer. It doesn't have to be like multiple choice or anything. Okay, good luck.